Hey everybody, let's try this again. I'm Mr. Collins. I'm one of the geometry teachers here at Battle. I may not be your geometry teacher, but I am one of them. And I created this review to help you out on the test coming up on Friday, okay? Now, the two things you should know about this review right away, and my intent is to work through all the problems with you from beginning to end, is that this first page should be taken to be like a checklist. And so once you feel comfortable with something, you can absolutely check it off the list, that you can 100% do it. And once you checked everything off this list, you should feel comfortable about the test coming up this Friday, okay? The second thing is, there are a lot of problems on this whole review, okay? A lot of problems. And there's so many problems here, I don't know if it's even fair to say that you should work every single one of them before the test, given that it's only a couple of days. So the way I've designed this review and the way I design most of my reviews is not intended to go like to the first page and then work all the problems, and then go to the second page and then work all the problems, and then go to the third page and work all the problems. The reason why it's not designed that way is because you'll probably get tired trying to do that, or you get frustrated trying to do that, and you'll eventually give up on the problems, right? And so like the way this is actually intended to work is like you should go to the first page and you should do about 1/3 of the problems. You can kind of notice how this is like split into 3 different sections. In fact, most of the pages are kind of split into 3 different sections. And so like what you should really do is like go to page 1, do about 1/3 of the problems, and then immediately go to page 2 and do about 1/3 of the problems, and then go to page 3 and do 1/3 of the problems. The reason why that's a smarter way to work this is like if you only have time to answer or to work 1/3 of this review, then at least you've seen all the different kinds of questions we can ask. And you didn't get tired after page 3 and just kind of give up and then never actually practice the stuff in the back. Okay? The other reason this is really smart is that if you do go through the entire review and you work like one problem off of every page, you again have seen at least a little bit of everything that's going to be on the test, and then you can go back and do that again. You can go back and like do another third of all the problems on each page. And then maybe Thursday night you take a last pass and you do another third. So essentially what you've done is like work 3 different practice exams over the course of doing this review. And that's how the video is going to go too. I'm not going to go page at a time. What I'm going to do is go through the test about 1/3 of the problems at a time. That way if you're really struggling, you can do them with me. Part by part or question by question, and you can work the review the way it was intended. Now, honestly, guys, you're high schoolers, you can do what you want with that information, but I'm just giving you a sense of how I would work this if this were me and taking this test, okay? So let's get to that. I'm gonna probably chop this up into like maybe 6 or 9 different videos, so each one's a little bit shorter than like a 40 or 50-minute monster video. But please understand the intent is to go through this review 1/3 at a time, and then reset to the beginning and do 1/3 at a time again, okay? So having said that, let's jump into page 1. Let's work through these first 6 problems. Now notice here, like the topic is 2 lines cut by a transversal, and we're just trying to name the angle pairs, that's it. And so we're not trying to determine if they have a further relationship, we just wanna know, based on where they are, what I should call them. So number one thing, we have to kind of at least in our heads identify the 2 lines that define our angles, and of course the transversal that creates those angles. And so if we look at angle 1 and angle 2, they're located in between the 2 blue lines, but also to the right of the transversal, which means they're going to be on the same side in terms of the transversal, and between the lines, interior, and so we can definitely call these same side interior. Okay, moving on to example 2. Here we have the 2 lines. We don't know if there's anything special about them, they just exist. Here's going to be our transversal that cuts them. We can notice that the angles in this particular configuration exist outside the 2 blue lines, but on either side are alternating the transversal. And so this one will be alternate. I have to abbreviate for space, exterior, EXT angles. Okay. This one's an interesting example because like the angles, if you notice, they're not completely on the interior space or the exterior space, but instead they kind of exist in the same relative location. What I mean is like angle 1 is kind of left of the transversal and below the line. Angle 2 is kind of left of the transversal, also below the line. We're going to call those corresponding. Okay. Example 4, again, 2 lines cut by that transversal. And if you see where the angles are, they're both on the interior space, they're both on the inside part of the 2 lines, but they're going to be one on top of the transversal, one on the bottom, so they're going to be alternating. I'll have to use some abbreviations here. In this case, interior, INT, and I'll use the angle symbol to shorten that to angles. These next two are quote unquote tricks, right? So they're trying to trick you here because like we don't really have the two line configuration. We just have two angles that are across each other from an intersection. We're going to refer to those as vertical. Okay, or vertical angles, I guess. Okay, and here we have two angles that form a line together because they're adjacent, and we're going to call these linear pairs. Okay. Also, your teacher may have referred to these as supplementary. So go with what your teacher went with too. All right, so I'm going to go ahead and stop on this page here. I'm going to now go to the other page. I'm going to leave the rest of the problems for another pass through the review. Okay, and I'm going to do one of these problems. Let's just do the first one. Okay, and so here we have to notice that the change that we now have parallel lines cut by a transversal. Although we do still have this nice transversal that runs kind of down and connects the two. If we notice the position of the angles, they're outside the two lines, but yet they're alternating the transversal. And so we're going to call these alternate exterior angles. By definition, if the lines are parallel, which they totally are, alternate exterior angles are going to be congruent. If they're congruent, that means our angle values are going to be the same. In this particular case, we can say that 2x minus 45, minus 45 is going to be the same as 4x minus 245. Okay, so the advice I'll give you is if you get to this point where you actually now have the equation, don't let the algebra beat you. Like, have confidence that you know how to solve it from here. As far as we go, we should probably get all the x's to one side. Okay, so let's subtract the 2x on both sides. Okay, that will leave us with negative 45 on one side, 2x's minus 245 on the other. Continuing to get x by itself, let's get rid of this negative 245. This is going to be plus 245. Well, I don't know what that line's about, but we'll just leave it. There's a new one. Okay, 45 plus 245 leaves us with 200, 2x. Let's divide out the 2's, and that leaves us with x to be exactly 100. Now, this seems like it's probably the right answer, but we should go back to our original diagram and test it. What I mean by testing it is that we should substitute the x value back in for the angle value, and let's see if it actually matches. If we know we're correct if both these angles are going to be congruent, because that's the known relationship. And so for the top angle, we have 2x minus 45. That will turn into 2 times 100 minus 45, and so we have 155 degrees for this top angle. On the bottom, we have 4 times 100 minus 245. Oh, look at that. It's going to be 155 degrees. Guys, that's not a setup. I actually wrote most of these problems, but I never solved any of them. And so this is actually me checking my own work. So knowing that they're both 155 degrees, once I use my found x value, I know that we're going to be correct. All right. Let's move on to page 3. The rest of the problems are going to be just like this one. And so I'm going to save those for later, because I'm going to go through this whole test again in my next 2 passes. All right, so here we have an upgrade to the problem. It's going to be a little more difficult, but we should notice commonalities. So we do have 2 parallel lines, and we do have a transversal. In fact, I think we have 2 transversals. I think it's going to be special about this problem. We have the 2 angles that exist between the 2 red lines. Okay, and they're both on the right of the transversal, so we have another set of same side interior angles. By definition, same side interior angles are what we call supplementary. Okay, which means that I'm going to add things together to total 180 degrees. Now in this particular case, the things I'm adding together are my angles. The ones that touch the blue transversal are going to be 6y plus 32, and also 10y minus 10 and 20. 10y minus 20, excuse me. Now I'm going to be limited on space here, so I'm probably going to compact some of my steps, but I still need to collect all the y's together. That's going to be my 16y, and it looks like it's going to be plus 12. That'd be 180 degrees. In terms of solving, let's subtract out that 12. And so that'll give me 16y to be the same as what, 168? 168. Okay, so when I divide by my 12s in my last step, or I'm sorry, divide by my 16s in this last step, I have the y value to be 168 divided by 16. So y is going to be 10.5. Now, several people have expressed like concern when they get a decimal. Guys, a decimal is a number just like anything else. It's Okay. So again, we should probably check this. So let's do a quick substitution. So we have 30 times x minus 10. That will turn into 30 times 4 minus 10. That'll be 110 degrees. And again, we're not looking for congruency here. We're looking for supplementaryism, excuse me. So 5 times 4 gives us 20 plus 50 is 70 degrees. And together, those are going to make, of course, our 180 degrees. Okay, guys, this will be the end of part 1. And so in the next video, I'm gonna go ahead and do the next 3 problems on each page. And then we'll just keep rotating in. We'll just keep working it on. Thank you. I'll see you in the next vid.